Hello, 7th graders. We're going to be solving two-step inequalities today. So let's get your page set up for some notes. So the objective for today is I can solve two-step inequalities. Okay. So for the most part, inequalities are solved exactly the way that equations are. So if you're proficient at solving two-step equations, this is not going to be much different from that. The only slight change is that when you multiply or divide by a negative number, you're going to have to flip that inequality symbol. So let's do some examples with that and without that. Okay. Let's start with a pretty straightforward example. Okay. We're going to solve this the exact same way that we do the two-step equation. So I'm going to start with my balance line. What happens to one side of the inequality has to happen to both sides. I'm going to locate my variable. Now there are two things happening. You're multiplying by 3 and you're adding 4. We always undo the addition or subtraction first. So the opposite of adding 4 is subtracting 4. So I'm going to do that here. Now what I do to one side of the equation, or the inequality, I'm going to do to the other. So this is 3m is greater than 21. Okay. Now there's only one thing left with your variable. You're multiplying by 3, and the opposite of multiplying by 3 is to divide by 3. So you get that m is greater than 7. Now with inequalities, I do ask that you graph it and check your answer. So let's go ahead and graph this inequality. Okay. Now, I've said it a lot of times before, but you don't need every number on here, just a couple on each side so that it has a context. Okay, now we know already that if it is greater than without the equal to line underneath, then it's going to be an open circle. It is open because 7 is not one of the solutions. In this case, it's going to be everything that is greater than 7. Now, if you're not sure which side to shade, I would recommend plugging in some numbers on either side to see. So let's try 5. Is 5 greater than 7? No. So it's probably this side over here. Let's double check though. Is 9 greater than 7? Yes, it is. So we're going to shade this side over here. Okay. Now the checking portion is something that still seems to be confusing to some people. So let's just start with checking to make sure 7 is the correct point to have the circle on. The way that we do that is we turn this into an equation. And we're going to put 7 in here for m. And we're going to make sure that 7 is going to make this equation true. So this is 21 plus 4 is equal to 25. This is 25 is equal to 25. So you know that the circle is on the correct point. Okay? Now we want to check and make sure that the shaded area is correct. So again, I'm going to write the original inequality. We're going all the way back to the beginning before anything has happened. A lot of people are tempted to pick an equation somewhere along the way. We want the very first one that we started with. And we're going to pick something in that shaded area to plug in for m to see if it's true. I'm going to plug in 9. So 3 times 9 plus 4 is greater than 25. So this is 27 plus 4 is greater than 25. And this is 31 is greater than 25. This is a true statement. 31 is greater than 25. So you know that your circle is correct and your shaded area is correct. Okay? I'm going to have you try a couple on your own, and then we're going to get into some examples that have that dividing by a negative number or multiplying by a negative number, so we can see what happens when that sign flips. This is number 1. 8x minus 12 is less than or equal to 12. And here's another one. I'm going to scoot this up a little bit. We're going to do 1/2 times x plus 2 is greater than 0. Okay, so what I'd like you to do now is pause your video, try these two problems. I want you to graph it, check your solutions, and then once you feel like you're ready, you can click play and check your answers. So pause the video now. All right, let's see how you did. I'm going to start with my balance line. I locate the side that has the variable. You're multiplying by 8 and then subtracting 12. We're going to undo our addition and subtraction first, always. So I'm going to add 12 to both sides. Now negative 12 plus 12 is 0. That's what we wanted. Now the whole part of this this term here has gone away. So we're going to be left with 8x is equal to 24. There's only one thing left happening to your variable. You're multiplying by 8. So we're going to divide both sides by 8. That is the inverse operation. Oops, I wrote the wrong symbol there. Let's make sure I keep that correct. Divide this by 8 and that by 8. So you get that x is less than or equal to 3. Kind of a short on space here, but well, I'm going to squeeze my number line in here. Okay, put 3 here, add a few numbers on each side for some context. Okay, now since this symbol is less than or equal to, we know that 3 is a solution. So I am going to fill in that circle. Okay. Now we want to see which side to shade. If you're not sure, just plug in some numbers. So I'm going to plug in 1 here. Is 1 less than or equal to 3? Yes, it is. So I'm going to shade this side. If you want to double check and make sure, you can always plug something in from the other side. Is 5 less than or equal to 3? It is not. So 5 is not a part of that solution set. Now I'm going to check my answer. Just a reminder, you're checking 2 things. We're going to check and make sure that 3 is the correct number to have that circle on. I plug in 3 for x. Okay, it works. 12 is equal to 12, so we know that 3 makes this equation true. Now we're going to start with our original inequality. And we're going to plug in something in that shaded area. I'm going to choose 1. So I put that in for x. Okay, so this is 8 minus 12 is less than or equal to 12. 8 minus 12 is negative 4. Is negative 4 less than or equal to 12? Yes. So we know that this is the correct solution and the graph is correct. Let's try this one, number 2. I'm going to go ahead and put a balance line down here. I locate my variable. You're multiplying by a half and you're adding 2. We always undo the addition and subtraction first. I'm going to subtract 2 from both sides. And I'm left with 1/2 x is greater than negative 2. Now, this is the one that tends to get people. If you're multiplying by a half, the inverse operation would be dividing by a half. You can do that. But another method would be to multiply by 2. Because if you multiply 1/2 by 2, you're going to get 1. So you'll be left with just 1x. And that's the goal. We are trying to isolate that variable, get it all by itself on one side of the inequality so we can see what it is equivalent to. So let's go ahead and I'm going to do that. I'm going to multiply both sides by 2. Okay. So I get that x is greater than negative 4. Okay, let's graph it. Just a reminder, when you're graphing negative numbers, they go backwards. Because without the negatives, it would go 2, 3, 4, 5, 6. But with the negatives, it's going the opposite direction. Okay. Now it's going to be a hollow circle because it doesn't have the equal to sign. And it says x is greater than negative 4. Let's plug a couple things in. Is negative 6 greater than negative 4? It is not. Think about it like money. You can owe somebody $6 or you can owe somebody $4 who has more money, right? Negative 6 has less money than negative 4. So let's go to this side here, negative 2. Is negative 2 greater than negative 4? The answer is yes. It's a much better position to be in to owe somebody $2 rather than $4. We would consider somebody that owes somebody $2 to have more money than somebody who owes someone $4. Okay. So there we have it. Now let's check our answer. I'm going to scoot this up just a little bit. All right, so first of all, I'm going to check to make sure that negative 4 was the correct circle point. So I'm going to plug in negative 4 here. A positive times a negative is a negative, and a half of 4 is 2. So this will be negative 2. Negative 2 plus 2 is 0. So I know that that circle is on the correct point. Now I'm going to check to make sure that the shaded area is correct. I'm going to write down my original, up here, my original inequality. And I'm going to choose to plug in negative 2 because negative 3 times a half is going to be a little trickier than negative 2 times a half. So this is positive times a negative is a negative. A half of 2 is 1, so this will be negative 1. Negative 1 plus 2 is 1. 1 is greater than 0. So our inequality is correct and our graph is correct. Okay, let's turn this over. We're going to try some now that have that special rule that we talked about last time. Pull this down a little bit. Okay, so let's do an example then where we have that special rule. Okay, so here's our equation. We're going to approach this just like we did on the other side of our notes. I'm going to start with a balance line. Okay, I'm going to locate the side with a variable. You have two things happening. You're dividing by negative 2 and you're adding 7. Well, we're always going to undo the addition or subtraction first, so I'm going to subtract 7 from both sides. Okay, so I'm left with this right here, x divided by negative 2, and then 2 minus 7 is negative 5. Okay. Now, I have one thing left happening to my variable. I'm dividing by negative 2. The opposite of dividing by negative 2 is multiplying by negative 2. So I'm going to do that here and here. Negative 2 times negative 5 is 10, positive 10. Negative 2 divided by negative 2, that cancels out. It is 1, so you're left with 1x. Now, I multiplied both sides by a negative number. That is a circumstance that will cause that inequality symbol to flip sides, like this. Okay. So let's graph it. And you know what? I'm just going to put a little note here, just so that we can remember what we did. Flip symbol. And I'm going to put in parentheses that we multiplied by negative 2. That is why the symbol was flipped. Okay. Now let's put some numbers here on our number line. This is going to be a closed circle because you have the equal to sign underneath. That indicates that 10 is a solution, so we want to shade it in. Now we're going to pick some things to plug in and see which ones are correct, which side is the correct side to shade. So let's start with 8. Is 10 greater than or equal to 8? It is. So I'm going to shade this side. Okay. Now we want to check our answer. Now this is important, especially when you start getting into with a special rule. Sometimes it's overlooked. And so if you're checking your answer and you find that the shaded area is not working out, then you probably missed this step of flipping the sign and you need to shade the other side. So while we're checking the answer, I'm going to talk to you about some errors that I've seen students make in the past. Some students just get really worried about missing that step. And so they basically flip the sign every time they see a negative. Don't do that, okay? The only time you need to flip the sign is when you are multiplying or dividing both sides of the inequality by a negative number. Now, you can subtract or add negative numbers to both sides, and you don't flip the sign. It's only when you multiply or divide by a negative number. So you can see that 10 was the correct place for that circle. Now we're going to check and make sure that our shaded area is correct as well. So I'm going to plug in 8 because that's, and check it out. This is super important with this. Start with the original inequality. So let me write that down. That's a negative 2, by the way. It's kind of messy. So now I'm going to pick something that's in that shaded region to test. So I'm going to do 8. So 8 divided by negative 2 plus 7. So 2 is less than or equal to negative 4 plus 7. 2 is less than or equal to 3. This is true. So we know that the answer is correct. 10 is greater than or equal to x. Now you're going to see that, sorry, I'm distracted. Somebody's knocking at the door. If you were to do all of this and this part was not functioning correctly, then you probably shaded the wrong side, okay? And you probably forgot to flip that symbol somewhere along the way. So let's go ahead and I'm going to give you some practice problems. Just a moment. Sorry, somebody was knocking at the door, but they walked away finally. Okay. And I'm going to scoot this up. Practice makes perfect on these. if you're not doing your handouts, you are gonna struggle. You need practice. You need to be exposed to these types of problems. So if you think you can get by without doing any work on these, you're gonna really shoot yourself in the foot on this, okay? Okay, so here's the first problem. And I'm gonna come down quite a ways because it seems to take a lot of room here. Okay. Okay, so go ahead and try these problems. Pause your video, give it some time, work through them, and then I'll show you the answers in just a moment. All right, let's see how you did. I'm gonna go through it pretty quickly so that you can get to your answers here. Okay, oh, I keep making that line too long and then I run out of space for my number line. Okay, I'm gonna do everything like I normally would. Okay, you may have noticed I forgot something. Okay, when I divide both sides by a negative number, I need to flip that symbol. Hopefully you caught that. Okay, so I'm gonna flip this the other way. All right, let's go ahead and graph it now. Okay, it's gonna be an open circle on 2. We're gonna shade everything that is less than 2. So let's try it out. If we plug in 0 here, is 0 less than 2? It is. Okay, I'm gonna quickly check the answers here. So -3 times 2 minus 5 is equal to -11. This is -6 minus 5 is equal to -11. -11 is equal to -11. So we know that point where the circle is correct. Now we're going to plug into our original equation something in that shaded area. I'm going to choose 0. 0 just actually makes things a lot easier. I use this original equation or inequality up here, nothing below that. So this is going to be 0. So this is -5 is greater than -11, which is true. So all of this is correct. All right, let's check that second one. Okay, I'm going to locate my side with the variable. I'm multiplying by -1/2, adding 2. So I'm going to subtract 2 first. So this is -6 is greater than or equal to -1/2 x. Now this is one of those circumstances where you could divide both sides by -1/2, but I think it's easier to just multiply by -2, because a -1/2 times -2 is going to be a +1. Okay, so this is going to be 12. And because I multiplied both sides by a negative number, I'm going to flip this symbol. Okay, let's graph it. I'm going to do a closed circle on 12. Let's try something to see which side to shade. Is if I plug in 10 here, is 12 less than or equal to 10? It's not. So let's try 14. Is 12 less than or equal to 14? Yes, it is. So we're going to shade this side here. All right, let's go ahead and check our answer. I'm going to plug in this first of all to make sure that the point is correct. good there. Now let's make sure that our shaded area is correct. I'm going to plug in 14 here. I could have plugged in 13, but it would have been a little messier, because then you would have had a fractional answer. So this is going to be -7. Is -4 greater than or equal to -5? It is. Okay, so this is the correct solution. So the takeaways from today is the only time you flip the inequality symbol is if you multiply or divide by a negative number. Just keep that in mind. Other than that, you solve them just like you would a two-step equation. You're just graphing, okay, besides that. All right, let me know if you have any questions the next time I see you. Make sure that you're working on your handout to get some practice. Thanks.